All right. Final project presentation for data science, data analysis. Alexander Britton. So for my data set, I'll read this off and then kind of go in more. For my project, I chose to do data analysis on a data set that features website traffic. I chose this because I know that web traffic metrics and data are a massive part of how AI is utilized. I will be working with AI for my entire career, so I make sure that I am familiar with some of the data that I may encounter. This data isn't the most exciting, but it is important. I will be referring to the dataset as just web data for the rest of this presentation. What it contains, so the data set has 7 columns. There's page views, session duration, bounce rate, traffic source, time on page, previous visits, and conversion rate. All the values are numerical except for the traffic source. Traffic source had 5 unique values within it, and it was basically like organic, referred, like there's a few different terms in there. Everything else was numerical, the conversion rate being the independent variable, the output, and all on a scale of 0 to 1 on the conversion rate, which I imagine was a percentage of how often, you know, those statistics led to the desired behavior with the website, the desired interaction. I don't know if it was sales or maybe it was just, clicking enough times on the site and interacting with enough. I'm not sure exactly. The data set when I downloaded it gave me information about it and said the conversion rate was the retention of members. So maybe it's if they sign up for a membership or they log in. The page views, session duration, traffic source, time on page, and previous visits are all pretty straightforward. Bounce rate is how often somebody opens the site and then immediately leaves without going in any further, so they just bounce right off the front page of it. My initial observations. When I first took a sample of the web data, I can see that the values all have different ranges that they span. And the size of the data frame that I built using the web data is 2000 by 7 in size. The non-numeric column only has 5 unique values. There were 0, null, or not a number values in this web data, so cleaning it was rather quick and easy. I viewed the minimum and maximum of each numerical column as well as the standard deviation, the mean, and the interquartile values. I used one-hot encoding to check if the unique values of the traffic source column would be relevant to the prediction model. After seeing how little they correlated with the conversion rate column, I decided not to include them at all. So it's basically like I took it and I made the, one hot encoding creates the binary values for each of the unique values in that column, so it separates them. And the correlation matrix or the heat map with that included, they had the most insignificant impact on the conversion rate. And so I just wound up leaving them out completely for my analysis. I did 2 sets though, because I had to come at this from a couple different angles, just because the output was kind of weird, just because of the way the prediction model works and the data works. So for my analysis, the web data was seemingly straightforward to clean and statistically analyze. It wasn't too difficult. I didn't really go too hard on the final project thing. But my correlation matrix and heat maps showed the values affected the conversion rate the most. The box and whisker plots for these different dependent variables showed what seemed to be many outliers. So when I looked at, like I brought up a bunch of plots for the values that were highly correlated to the conversion rate, and I looked at them with box and whisker plots, and basically majority of this data was crunched into having a value of 1 on the conversion rate, and that was the majority of the data. And so because the minimum was for a lot of them was about 75% of that, so like 0.25 for one of them, or like the extent by which this data traveled before it kind of smashed itself up against all these entries of 1 in the conversion rate meant that the range might have spanned that distance from the minimum to 1 on the conversion rate, but the number of entries within that range were just massively populated towards the 1. So it started to look like there was a bunch of outliers when really it was just very consistent data. So this one I said pain in my analysis. I really didn't like this graph when I brought it up. The conversion rate column of the web data ranges from 0.34 minimum up to the 1.0, and over 1,750 of the entries in the web data have a conversion rate value of 1. Box and whisker plots would show that most of these values are outliers simply because the range of values was barely populated underneath values closer to 1. I split the data, applied a scalar, fit the model, and ran the predictions. So it came out like, if you look at this graph here, you can tell the predicted data is, I mean, it's clumped right around 1, but it goes above it. That was the first issue. And the actual data is just piled right on 1. Like, all of those entries are right on 1. So, did a few things. This didn't change the performance of the model. That's one thing I know for sure, just because it just kind of a way to make it look prettier. But the model's performance wasn't bad since all the predicted value outcomes were very close to 1, the most commonly occurring value in the original data. Also, the model was giving some predictions over 1, even though those values never occur in the data, and they can't. I'm sure there was a way to window that early on, but what I just wound up doing was rounding it to a single decimal place, because like the decimal places on these went out to like the millionths or something. It was crazy, and I didn't like the way the graph looks, so I decided to start behaving in a slightly fraudulent way. I guess it's because this is basically cooking the books a little bit to make it look nice. But yeah, since the values that were stored in the conversion rate column had a decimal placement to the millionth or something like that, I decided to round the values down to 2 decimal places or 1. Now the prediction values align very closely to the actual values. This doesn't change the performance of the model, but does make the data look better when graphed. And that is it for me.